Hi, long time no see, I think. I think I made my last video quite a bit ago. So yeah, today we will be discussing topic 4 of IAL Edexcel Chemistry. It's Intro to Organics. So in this chapter, it's a little bit of a broad chapter because you need to, get into the basics of organic chemistry. So this is part 1. I am guessing I can finish it in part 3. I hope. But yeah, let's get into it. So we're going to first of all discuss what hazard and risk is. So these are two different things. They're not the same thing, okay? So hazard is something that could cause harm to the user, okay? So it's more of, what kind of danger you are subject to if you're using something like a chemical. And risk is the likelihood or chance or probability of the hazard causing harm to the user, basically. Okay, so yeah, that is how it's different. And so these are the types of hazards. These are probably just symbols that you can see on bottles of chemicals in your laboratories. So this first symbol says health hazard. Okay, sometimes it's also called irritant. So you should probably not drink it. Okay, and don't touch it probably. And this sign is pretty obvious. This is a flammable sign. So it's chemicals that can catch on fire pretty easily. So obviously you shouldn't use naked flames. And over here, this sign actually looks very similar to the flammable sign. So you should be careful. But this is for oxidizing liquids, okay? So there is a circle right in the middle of the flame, okay? That is an oxidizing liquid sign, okay? And we have the corrosive sign over here. So you can see that this solid structure is being eroded away because of this chemical, right? And it also could cause the same kind of damage to your skin as well. So obviously don't touch it. Corrosive. You should wear gloves when you're handling these kind of corrosive chemicals. That would be, a safety precaution. And over here we have this toxic sign of a skull. Okay, so that is toxicity. Those are some types of hazards that you might see in exam papers, okay? So there are some ways to reduce risks. These are working on a smaller scale, first of all. So first, you can dilute acids or alkalis used in titration so that their concentrations are very low because they're corrosive, right? And only adding a very small amount of sodium metal in water when observing reactions of group 1 metals with water, because group 1 metals react very vigorously with water. So for example, like with potassium, it literally burns. Okay, it catches on flame, okay? And there's a lot of effervescence of hydrogen gas being produced, okay? So that is working on a smaller scale, and we have the 2 additional ways to reduce risk, which is use an alternative method involving less hazardous substances and taking precautions specific to the hazard, like using a fume cupboard, wearing gloves, not using naked flames, and using a water bath instead. So let's investigate those, okay? So for example, a reaction is giving off toxic fumes such as the hydrogen chloride gas, sulfur dioxide gas, or carbon monoxide gas. These are the most common gases that are toxic that they talk about in exam papers, okay? The safety precaution you would take is to work in a fume cupboard so that you're not exposed to those gases being produced in the reaction, okay? And if you're working with flammable substances and you must apply heat to that kind of substance, you should not use naked flames to heat them. You can use a water bath instead, okay? Because with a water bath, the flammable substance will not catch on flame. So in this example, we have ethanol, which is flammable. You might have to warm this ethanol to be used, for example, testing for halides with silver nitrate. You don't have to know this right now at this level, but yeah, sometimes you have to heat ethanol to a certain temperature, but if you use naked flames to do this, it can catch on fire and you might be hurt, the risk is increased. So now we're going to discuss some concepts such as homologous series and functional groups. Okay, so first of all, homologous series. Pretty sure you've came across it in GCSEs, but each series is a group of compounds that have the same functional group. Okay, so therefore they have similar chemical properties and they show a trend. Okay, if they vary in number of CH2 branches. So that's the second point. So they have the same general formula, okay? And they only differ in the number of CH2 branches, okay? So that's why they show a trend. These are 2 points that you must write when they tell you to describe what a homologous series is or define homologous series. So I highly recommend just memorizing these 2 points, okay? And functional groups, these are groups of atoms or a bond that determines the chemical properties of a compound. Okay, so from GCSEs, you must have looked at some of these functional groups, such as carbon-carbon double bond in alkenes, that's the homologous series, and the functional group of alcohol, so OH, and carboxylic acid group's functional group would look like that. A carbon bonded to OH and also bonded to an oxygen with a double bond, okay? So yeah, those are some functional groups that you would have looked at before. And yeah, so the different homologous series we're going to discuss first of all are alkanes, which are basically saturated hydrocarbons. I'm hoping that you remember what saturated and what hydrocarbons mean. Just in case you don't remember it, saturated would mean that it only has single bonds, and hydrocarbon would be any compounds, specifically organic compounds, that are only made up of hydrogen and carbon, okay? So, and alkenes, they are unsaturated hydrocarbons because they have carbon-carbon double bonds, so that is their functional groups. Okay, and alcohols, they contain the OH group as their functional group, carboxylic acids, COH group, and esters. Esters are made up from alcohols and carboxylic acids, and they basically undergo condensation reaction, and it forms this ester bond. So the carbon is bonded to O and double bonded to O, like that. And as you can see on the drawing. And we will be looking at more homologous series like ketones, aldehydes, nitriles, amides, amines, and such. But for now, we're just going to, solidify alkanes and alkenes, okay? Yeah, so more in the future. So we need to look at naming systems. So IUPAC nomenclature. It's the International Union of Pure and Applied Chemistry, I think, if I remember correctly, but it doesn't really matter. They won't ask you what IUPAC stands for. Anyways, IUPAC nomenclature. So first of all, this is the naming system, by the way. You probably have came across meth, eth, prop, bute, I think. But now you need to know pentane, hexane, heptane, octane, nonane, decane. So these are the carbon chain lengths, okay? Different names for different carbon chain lengths. So first of all, the easiest example is methane. So this is the alkane, the shortest alkane possible. So CH4. And if we have a methanol, an alcohol with an OH group, it would just look like that, and you would call it methanol. And if we have a carboxylic acid, then you would call it methanoic acid. So oic acid comes after your, carbon chain length, okay? And now we can see the naming for alkenes. No, the ethene, you already know how to probably name alkenes from GCSEs. But yeah, if you have two carbons bonded by a double bond, then you will call it ethene. Okay. Obviously, you wouldn't have methane, right? Because if you only have one carbon, there cannot be a double bond. And this guy over here is a butene. Butene. Yeah, because we have 4 carbons and we have a double bond. But butenes can be different. So we can have this butene and this butene. So let's see how they're different. So I numbered the carbon from 1 through 4, and over here as well, 1 through 4, 1, 2, 3, 4, 1, 2, 3, 4. And we can see that the carbon-carbon double bond on the first example is on the first and second carbons, right? And on the second example, we have it on the second and third carbons. So we named the first example but1-ene and the second example but2-ene, where the number basically indicates which carbon the functional group is attached at, okay? So the number comes first, and then ene, the functional group indicator, comes in, okay? I hope that was clear. And yeah, we also use the smallest numbers possible. So we don't call but2-ene when we have the double bond on the first carbon as well. Over here, the carbon-carbon double bond is on the second and third. So we would use 2 in the name, okay, instead of 3. Right, and so a common mistake when the double bond basically go to the end, people might count this as the first carbon on the very left and then say that this is but3-ene, but this is just but1-ene because you can count from the other end, okay? So count from right to left, so that's first, second, third, fourth, then it's just but1-ene. It's just basically, you know, a flipped image of this structure below, okay? So they're the same thing. But1-ene, that's but1-ene, that's but1-ene, right? Be careful. And if we have different functional groups, it's kind of the same. So if we have this over here with an OH group attached on this carbon, it would be butan2-ol, because you can say that that's the second carbon counting from the right. And if we have the OH group on the end, that would be butan1-ol, okay? In the case where this OH group on the second carbon moves on to the next carbon on the left, that would still be butan2-ol, okay, because it's just flipped images, right? It's not butan3-ol. Just be careful. And now let's look at some branching. So I have this structure. Let's pretend that I drew all the hydrogens on, okay? I was just lazy. First thing you need to do over here is to identify the longest carbon chain, okay? So if I count, we have 5 carbons bonded all together. So it's a pentane, first of all, okay? And we have this guy over here, which is called a methyl group. So generally, like branches that have just carbon and hydrogen, we just call them an alkyl chain, okay? Alkyl chain, and meth over here just stands for 1 carbon, okay? So we have a methyl group there, and it's on the second carbon. So the name would be 2-methyl and then pentane, okay? 2-methylpentane would be its name. And if there is a carbon-carbon double bond, you know, it's a functional group, right? We need to prioritize the carbon with the alkene group because it gives, you know, a chemical property, okay? So we're going to count from the right, so 1, 2, 3, 4, 5, and now the methyl group is on the 4th carbon, right? So the name would become 4-methylpent1-ene, okay? I hope that was clear. Yeah, notice the ene because now it's an alkene. We could also have more than 1 branch. So if you look at this molecule, you can see, first of all, you need to identify the longest chain, you know, with 4 carbons. So we know that it's but, and let's say that this is an alkane with no other functional group. So everything, all the hydrogens are just attached to all the carbons. And it has 2 methyl groups on the second carbon, as you can see. So therefore, we name it 2,2-dimethyl-butane, okay? So di-methyl would mean, di means 2, and methyl is the CH3 group. And the positions are indicated by these 2 numbers, 2,2-dimethyl. So you can't just put 2-dimethyl because then you don't know the position of the other methyl group. So yeah, 2,2-dimethyl-butane would be the name for this structure. And what if the branch length is longer than 1 carbon? So we have this structure over here, and if we look at the longest chain, it's a hexane. We have 6 carbons as its longest chain, and we have an ethyl group now. So I just told you that it's, the general name for a hydrocarbon branch is an alkyl group, right? So you just take out the al thing and then just put the meth, eth, prop, but, and on and on. So over here we have a branch with 2 carbons, so it should be an ethyl group, okay? So try and guess what this name is. It's pretty easy. You can pause the video, but I'm gonna reveal the answer, which is a 3-ethyl hexane, okay? So yeah, that is, I think, it. And I wanted to tell you that to be careful not to count from the right, because if you do this, you would end up with 4-ethyl hexane. But we want to make the name so that we have the smallest numbers possible, right? Yeah, so that was the last thing I wanted to mention, I think. And I will be discussing about different formulas, displate, skeletal, and those kind of formulas, and more about alkanes in the next video.